Hi everyone, this is Sangeetha working as assistant professor in IoT department at SNS College of Engineering. So this session I'm going to discuss about the recovery algorithm. So before that we're going to discuss about the types of failures, which is there, and the storage structure, what kind of storage structure we have to follow, and recovery in atomicity and object recovery mechanisms. So failure classifications. So the failure classified into these categories: transaction failure first. So the transaction may get failed due to some reasons. So due to the logical error and also system error, the transaction may get failed. So logical error means the transaction cannot complete. If there is a logical mistake, due to that some internal error condition, the logical error will happen. The same system error, the database system must terminate an active transaction due to some error condition like data. Due to the some insufficient resource, this transaction may get aborted. So this kind of transaction failure may called due to the system errors. And system crash is a powerful failure because power failure and other hardware and software failure causes the system to crash. So and disk failure. So it's a head crash or similar disk failure destroys all part of the disk storage. So the destruction is assumed to be a deductible. The disk drives use checksums to detect these kind of failures. Okay. So recovery algorithms. Suppose the transaction TA you want to transfer rupees 50 from account A to B. So there are two updates that way. One is subtract 50 from I and add 50 to B. So transaction TA require access to both A and B output. So the failure may occur after one of these modification means have been made, but before both of them are made. So modifying the database without ensuring the transitional commit so may leave inconsistent state. So not modifying the database may result in loss of data also. So we have to recover the stages. So the recovery algorithm have two parts. One is action taken after the failure occurs and action taken before the failure. The action taken during normal transition processing to ensure enough information exists to recover from failures. So, and another action taken after a failure to recover the transaction database content to a state that ensure the atomicity, consistency, and durability. The storage structure may categorize like a volatile storage, non-volatile storage, and stable storage. So if it is a volatile storage, it does not have survive system crashes because example, the main memory and cache memory data is when the power is switched off, the content stored in volatile memory like main memory and cache memory will destroy. In the non-volatile storage, it survive on the crashes also, but example, but may still fail occurs, so it may lose the data. So example, disk tape, flash memory, non-volatile RAM, these are all comes under non-volatile storage. And stable storage, it's a mythical form of storage. Survives all failures, approximated by maintaining multiple copy on distinct non-volatile media. So here, the data access in stable storage implementation, it maintain multiple copy of data on different separate disk storage. So the copies can be at remote sites to protect against a disaster, natural disasters such as fire or flood like that. The failure during data transfer can result in inconsistent copies. The block transfer can result in the successful completion and partial failure and total failure. The partial failure, the destination block has incorrect information. The partial failure, the total failure, it's never updated means it's total failure. So based on that, disk transfer will occur. The protect storage media from failure during the data transfer is a one solution. It is write the information on the first storage and assume if it is a successful, when the first storage is successfully complete, write operation again start with the second physical block. The output is completed only after the second write completely successfully completed. So protecting storage media from failure continued by copies of block may differ due to failure during output operation. To recover from failure, first find the inconsistent blocks and expensive solution also. So better solution use the recovery, find the block and maybe inconsistent only compare those copies and update by using wait systems. If either a copy of an inconsistent block is detected or error is detected, it's overridden by the other copy and have no error means if there is no difference means you can keep it. So the data access may be granted both the physical blocks and buffer blocks. The physical blocks are those blocks are residing on the disk and buffer blocks are residing on the temporary main. So the block movements were carried from disk storage to the main memory. So through the following two operation input and output. The input transfer the physical block to the main memory, the output to the main memory to the disk. So likewise, the transaction of data store access will take place. So there are two kind of operations are executed on the data transaction. One is read and one is write. Then this is the example of data access from the main memory to the disk storage and disk storage to the main memory, vice versa. So likewise, the data will be stored in the buffer and accessed by the transactions. So the transaction will also have a separate folder for the storing the data. The buffer is also having the log of storage, and likewise, the data access will takes place. Remaining recovery and atomicity we will discuss in the next class.